Good afternoon, everyone. Good afternoon, everyone, and so welcome to the RBCDSAI seminar today. And so we are very happy that after a gap of 2 years, we are able to do a partially physical event. And so this is a hybrid event, and we have about 15 people in audience, which I think is great. And it's really happy to be hosting Balaji again after a gap of almost 3 years now. Yeah, I think it is more than 3 years since she gave the last talk here, right? So Balaji is a long-time collaborator for the center and for several of us here. And he's a principal scientist at Adobe Research. And before that, he did his undergrad across the road, and then his PhD at University of Maryland, and then has been with Adobe for almost 15 years now.
10 plus years now.
10 plus years. Okay, I've been with Adobe for 10 plus years now. And Balaji works in a lot of very interesting areas and cutting edge stuff, both in language and vision and videos. And we're really excited to hear from him, and I really thank him for making time. And kind of I sprung it on him in the last minute, but he still gamely agreed to give this talk. So thank you, Balaji. And over to you.
Yeah, thank you, sir. So I think, yeah, like you said, it is. It feels different, and almost a gap of 2 years. I'm coming into the campus, and last I think I remember coming here post AAAI, sometime around that time, and 2020, before the whole lockdown happened. And I think it is. I mean, very happy to be back on campus, and thank you, sir. I think when Ravi sir first asked me if I can give a talk, the first reaction was, it's about 2 years since I actually came on a campus and gave such a more wider talk. We have given all the conference presentations in the remote world, which again has its own perils. But I think this, I mean, thanks for the opportunity, and I'm to present some of the works that we have done over the last couple of years in this space of the multimodal generation. And before getting into the details, I think, like Ravi sir said, I work as a principal scientist at the Adobe Research, and I think my own research interest spans across both the multimodal content generation or composition, as I would like to call it, or and more recently, we are also I'm also dabbling into what I'm calling as a cross-media generation, where can we generate, say, a video from a textual document, or how do you go from one media of consumption into the other media, and how do you automatically generate these things? And over the last several years, I have also been working on the natural language generation as one of the core topics. That apart, I also lead the team of researchers here from the Adobe Research India, and where we span across the space of the computer vision, NLP, and the human-computer interactions. And so we at Adobe Research, I think we have been largely been the technological hand of the larger company, and we have been inventing a lot of the cutting edge technologies. And as I mentioned, I think some of the research, I mean, I'll also articulate these as I go into the details of the different technologies that we have been working on. And I think one of the major things that we at the industry we pride upon is about how these research and how the different technologies that we develop eventually makes it into the products. And to that end, we have been working on stuffs that can go into that, I mean, around the spaces of computational creativity that yields into the larger Creative Cloud and the Photoshop line of business that Adobe has. And then we also have a large marketing cloud business there, where a lot of this user understanding and those things get in. And finally, about the document intelligence, where understanding the documents and their different manifestations, they essentially go into. So the reason I wanted to have this slide was to just, as I walk through the deeper the technologies and the algorithms that we have worked on, I'll connect back to some of how they are getting realized in some of these products and different businesses that Adobe has. And so these are some of our major research areas that we are working on, and I think we are working and I'll at least cover a good, in at least some of these parts in the part of my talk. So that said, so now let me get into the core topic of my presentation. So over the last few years, I've been looking at generating say multimodal content, and I think the word multimodal in itself, I think in the larger research space, has two kinds of flavors. One is more about the devices and the modalities on which you take the content. Like said, there is the one modality says about the mobile or various or the desktops or the large screens and the touch screens and so on and so forth. But then I think that is not the modality that I'm going to talk about here. To me, I think in this particular context of the talk, we're going to consider the different content modalities like say the text or the images and various other manifestations of the content. So this is not something that is new. So I think there has been a lot of psychological studies, which say that humans, we I tend to have a better understanding when we consume this content in multiple modalities. And this, I think, again, in this particular audience, I think all of us would be easy for us to understand. So we often use, say, a combination of. Hello. So, so we often use a combination of these modalities for a lot of our understanding needs. Say, for example, even in this particular presentation, we have a visual medium on the slides, and I'm also talking through that. And this combination is what yields the final this thing. And there are studies that say that these are very effective. And they are also very impactful. Let me show you one example that we came across when we began this work, right? I think this is what the psychologists, they call it as a meaning multiplication. Say in this particular case, there is an image and there is a text that says, not everyone who drives drunk, they die. Well, I think if you just look at the text on its own, it conveys one meaning, that I think it might come across as, say, something that is promoting a drunken drive, but I think when you look at it in the context of the image, it essentially conveys a more deeper meaning. And this, I think, in the context of the psychological studies on education, they call it as a meaning multiplication. So where I'm getting at is there is a lot of value in looking at, which we derive in consuming these content in multiple modalities. That said, and this is, before I get into the details of where we lie in the state of the art, we also wanted to do a more quick study with some humans on, do we really need these multimodal outputs in some of our generation systems? To that end, we started with first motivating ourselves, and then we went into a human experiment. So for this case, I think, say, suppose, how does a coronavirus look like? And if you look at just the textual description out here, it is fine. Once you know what it is, we will be in a position to say that this is correct. But often, I think the image, if you provide an accompanying image, they often provide a better grounding to the answer or to what the text describes. That apart, I think it also sort of provides. Let me just close this. So that apart, it also provides a better understanding of what it is. Say, for example, another so, for example, if for a question like the Shillag, I think it is sort of a kind of walking stick. But oftentimes, I think if you just look at the description here, it is just going to give certain information. But the image immediately says that this is a kind of walking stick, and so on and so forth. So to get a more deeper understanding, we went to a set of human annotators to whom we asked, so what are the, if this is a question and there is an answer that we are giving, what is the value that you derive? And we tried to ask across several questions. And what we found was almost for about 80% of these questions or things that we consume, the 80% of our respondents, they felt that the textual answers were more or less sufficient. But even amongst them, about close to about 90%, they did feel that the image always enhances that understanding. And of the remaining 20%, where people felt that the textual answers were not sufficient, say, for example, the walking stick example that I just spoke about, where an image could have enhanced that understanding, they felt that, among them, they felt that the image is always definitely adding up to that value. So this again motivates us more empirically from our human annotations that there is a lot of value in generating these content or creating these content or consuming them in multiple modalities. But that said, the generating from I mean about generating these content from existing sources of information, that is far from being solved. If you look at a lot of literature out there, so there are works around say the GPTs and the causal language models that looks at generating the text, or there are these different flavors of GANs that looks at generating the images, and so these are largely they just focus on a single modality, and that really doesn't cater to some of these consumption needs which would want these content to be generated simultaneously in multiple modalities. But having said that, there are also these other kind of works like, I mean, the DALI and the style clips and those sort of works, which are technically still an image generation problem, but they start with some textual cues and they try to seamlessly move from one modality to the other modality in terms of the generation and carrying over the semantics. So this was one of our early motivations. So these things are happening, and there is a lot of opportunity and potential in generating, say, more of coordinated multimodal fragments. Say, let us go. I mean, the example that I showed in my first slide about the drunken drive, that is the North Star example. But can we at least generate something where the text and image helps each other? Right. So that is the question that we are trying to address here. And to our help, I mean, there are lot of recent works with the transformers that are trying to go into these multiple modality spaces like clips and say the Wilberts and the uniters. So these are some models that try to capture the visual and the textual modalities into the same space. While the notion of multimodalities in the content need not be restricted to the image and the text combinations, at least for our initial explorations, we have restricted that to that so that we wanted to see if there is an opportunity and how we can generate coordinated multimodal fragments. So in this talk, I think that is the core, that is going to be the core theme, how we have used some of these recent advances in the multimodal transformer architectures for generating these coordinated multimodal fragments, wherein the image and the text, they have some correlations and together they try to address certain needs. And over the, I mean, in the course of this talk, I'll be covering three different works, that one on that was generating a teaser or a summary for a longer document for tailored to different users, and then I'll talk about how we use, I mean, how we generate, say, multimodal answers. And the last application is something that will, I mean, that is a sort of a different application in itself, that where we try to use these multimodal fragments as, say, some sort of a table of contents for a video and enhance the nonlinear consumption of a video. And I think at the core of, I mean, one string that ties all these things together is the ability to generate coordinated multimodal fragments, wherein there is an image and there is a image text fragments that that are purported to convey a particular goal, and that is what we have looked at in each of these applications. I'll go into the details of how we went about solving each of these challenges in the subsequent sections. So the first work around the generation of multimodal teasers. So the teasers are something that all of us we encounter in our web exploration. Say this was one screenshot, say, from a Medium blog, right? I think wherein there is a, say, if you're talking about this, how I went from zero coding skills to the data scientist in 6 months. So this is roughly a fragment that teases you into the underlying article, right? I think it essentially talks about someone teaching you about some coding and other things that is on the board, and then there is a text that essentially, I mean, in the combination, the intent is to attract some reader towards the underlying article, right? So, but teasers, I mean, you can think of the teasers as, say, some sort of a multimodal summary that will hook a particular reader into the underlying document. But there can be several, particularly because the documents are longer, particularly when the documents are longer, there is a good possibility that there could be multiple teasers for the same input content. Say, for example, I'm a traveler and I have a travel blog or something that I'm putting together, and there can be a sort of teasers that can cater to someone who is looking for more information about those places. So, or if I have to, I mean, sort of for a promotional purposes, there can be, say, the same content from the same document. It can be used to tease for someone who is looking for, say, some hotel bookings, or who is, I mean, or for the hotelers to use that for a branding purposes. And then there are also, say, sort of, you might want to say that if someone is looking for, say, some do's and don'ts or those sort of things, I mean, you can generate a different teaser from the same underlying document. So in this work, we tried to generate multimodal teasers for a document that can be catered to different user needs. So to more succinctly, the problem was you have an unstructured text and image content, which is the document input that I spoke about. And there is a target user need, and I'll talk about how we model the user need in a subsequent slide. We want to design a system that can synthesize these multimodal fragments that have to cater to information. Right now, if you sort of take a step back, and there is a lot of similarity of this problem to, say, what a typical textual summarization routine does. So we want to convey the core information of things that are present in the input content. That is similar. I mean, therefore, we want to represent that input content while addressing to the needs of the end user. At the same time, do this across multiple modalities. So this was the goal of the problem. And again, to go a bit deeper, so here, I mean, say the article text and images, that document is that input, and we want to essentially be able to say that if someone is looking for a fashionable content, so how will this thing be more fashionable, or versus someone who is looking for, say, some do's and don'ts like alerting, how should we go about generating those fragments? So here is a quick outline of how we went about at a very high level. We assume that there is a repository of images that can embellish the content that we get from the input document. Oftentimes the documents themselves, they might have the images, but in order to embellish that more, we assume that there is a corpus of images that are available at our disposal. So the first thing that we do is we essentially look at different parts of the input document, and we try to come up with a good collection of images that would be that would go hand in hand with different concepts that are represented in the document. So this is just to ensure that if there is a need, if there are certain images or certain visual content that are not there in the input content, how do we address that gap? So we essentially go and query a larger database and get those images. Say, for example, the image. So this article is about best places to visit in Australia. This is one of our test document, and the document in itself didn't contain any images about Australia or others. And so we generate a lot of different combinations of these concepts to come up with several queries that we issue into the image repository, and we come up with a lot of images. Say the image that you see on the top, that is of a landscape, and so on and so forth. And then we go about and we extract different textual fragments from the input, textual pieces from the input, depending on what are the key, which conveys a lot more information. So this is again a standard task of finding the information coverage within the textual modality. Now, in this particular case, we also went into So images, I think that keywords, they come. So there are two aspects here, right? One, the standard tagging that happens to image in the repository, we used that, and I think that is a good segue into the other one, right? I think wherein, so the column that you see here is the parallel and the non-parallel fragment. So there the tags are insufficient, right? Because at max, I think for the image on the top, what you would get is, say, there is a water body or there is a land region or something like those are the tags, right? So they fetch you at a very high level, but what we want is sort of connecting the semantics between the two. And to that end, we had some studies that say that some multimodal fragments, they can be of two parts. Like, I think this was a study that was done in the advertising literature where they wanted to connect the semantics. So they can be either parallel or non-parallel is what they say. So this level of semantics is very hard for the tags to get. So at that point we got into some of those multimodal representations that projects them into the same semantic space and use them for that. But for our initial querying and the retrieval, we use the standard tags that come with the images, because at that point we over specify and get more images, and then we filter it in the subsequent stages. So yeah. I'll show you in a bit. Yeah. So, so in this case, so once we have, so as we were looking at the advertising literature, so these advertisements often come with the images and the text, right? So I think in that, so there are studies that say that these fragments can be parallel or non-parallel. What they mean is, in a parallel fragment, the image and the text, they can technically talk about the same thing, so that the meaning is finally amplified. And then in a sort of a non-parallel fragments, so there is an image and there is a text, together they connect to the larger topic, but they are they are somewhere semantically connected, but they need not be having so much of an overlap. So this is the two kinds, and when we try to generate the teasers, we try to generate it in these two aspects. I mean, there are several more categorization underneath, but because this was the first exploration, we started here. And so we essentially used, like I was just saying, we used the multimodal representations to essentially figure out what is the semantic closeness between the images and the text. And we do a ranking on this one to find some initial categories of these fragments. And once we do that, then the final part is about the needs, right? Or rather, someone is looking for. So like in a lot of this content related works, so any of these needs are addressed both by the information as well as the style part of it. So that was the second aspect, where we, once we have identified an image text combination, we also use out of the box style transfer models style transfer models from both image and the text literature to tailor the respective dimensions to the target need. So now I have thrown out a lot of jargons here. Let me go into the details of each of them. So double clicking. Okay. So apologies if the slides have, I mean, often the Mac to Windows transformation leads to some visual distortions of the layouts, but I think we'll just live with this. But I think the idea is, so first, when we do the need based, I mean, as a first step, as I said, once with the input content, I extract, I construct a lot of queries, and we get a few images and find the top textual fragments from my input document. And now I want to do a matching. So in the matching, I essentially find the overall, use the overall relevance of the image semantics to the input document semantics, as well as the textual fragments, to do the initial matching. So that is what is the step here. But now that leads us to the other part I was saying, right? So there is a end user here to whom we want to cater. So we want to really understand. So if there is, how do we map, say, a user's intent or user's interest into the content, right? So there were, for this, there was an ads data set that was, I mean, released by the UPITs, where they had, for every ad, there was an image and there was a slogan, which was a textual fragment. And then they had notions of the sentiments that this ad was going to evoke in the end user. And they also spoke about symbolisms that are present within the ad. So there is a, so we essentially had a two-way rather, I mean, a two-staged mapping, where with every concept that was present in the image and the text, we mapped them to their symbolism. Say, for example, in this one, there was a wreck, which essentially means that it is symbolizing, say, danger. So that was the first mapping that we mapped. And then we used a second stage mapping, where there was this symbolisms, that is, a danger would essentially mean that you can use some of these content to alert a particular user, and so on and so forth. So there were a lot of these mappings that we started with. And then what we do is the following. So we have this mapping. So this helps us identify, for a given user intent, what are the kind of content that needs to go in. Now we also wanted to figure out what are the different stylistic aspects of the text that needs to be accounted for, as we are catering to the different needs. So to that end, we extracted different features from, say, the visual and the textual modalities, and we built a causal deconfounder models for each of these target user personas. So we use the personas like alerts and say the fashionables and other sort of the sentiments that were available in the UPITS dataset as a surrogate for the end user needs. And once we had this the causal deconfounder model that was built, so this essentially says that there are certain aspects of the images that are causally significant and certain aspects of the text. Yeah. So it is essentially a model that looks at, I mean, so long story short, I think the causal deconfounders are sort of mechanisms by which you identify if there are any correlations that are present between the independent and the dependent variables. You try to remove them so that what remains is something that are actually causing the output. Say, for example, in this case, there could simply be a correlation between high aesthetics and say high alert messaging, right? So I want to remove those dependencies, and I want to figure out which of them are causally significant towards the output objective, in this case, say the needs of the end users. And therefore I do this deconfounders and then figure out which of them are significant. And so this is what we do, right? I think then at the end of this, for every need, you identify certain aspects of the images and certain aspects of the text that are critical for that messaging, and then you can go and we then use the standard out of the box style transfer models to fix them. Say, for example, if the image aesthetics was supposed to be, we found that the image aesthetics often always is very high for fashionable messaging, which means that we had an aesthetics, style transfers that transfers an image of lower aesthetics into a higher aesthetics, and we just use them for our multimodal fragments. So, for example, we from an input article, we retrieve different textual pieces, we generate different images, and then we match and we get into, say, the different types of these fragments. And then we use the scores that I just mentioned to transfer, say, an image like this into a more reddish tinge that essentially indicates more of the alert uh, that caters to that alerting need better than the original image. So what at the end of it, what we had was, for every input article, we had a collection of multimodal fragments for different needs that could be a teaser. Now we want to, in order to evaluate this, we used a MSMO, which was just released at that point, which had a lot of this human curated summaries along with accompanying images. And the goal was, I think, remember, the summarization is just one part of the goal here, right? We want to also cater to the end user needs. So we used the data set from the PITSADS data sets to essentially come up with, say, some proxy metrics to measure how good the alignments are. To that end, so so going back to your question about how we ended up evaluating, so we had multiple variations of the system along with, say, the human annotations which came from the MSMO data collection. So we essentially started with looking at, the first objective was the information representation. So we wanted to see if the fragments that are generated by our pipeline, they are essentially catering to the summarization needs of the input document. So that we were actually, from the textual modalities, we were just resorting to the standard metrics of the roots, and there was already the promise. And then on top of it, we also wanted the image and the text to be relevant to the input article, so that so that it can be good enough for teasing that article. So that was the other, where we leverage some of this image semantic embeddings. And finally, we had, ways in which I think we used the data set from the PITS ads thing to model how this is relevant to the need. So we took all the data, all the things that were marked as, say, alerts or, say, fashionable and others. We averaged their features and used the distance of these fragments to that as a proxy for the relevance to the need. And finally, we also wanted the overall fragments to be diverse. And so we had our the inter fragment similarities and their distance to measure the diversity. Again, in all these cases, I think these are highly subjective tasks, right? So I think ultimately we also have to go into a human experiment where we wanted to ask them how these things are aligned for a target need, right? So those questions were pretty straightforward, but real test of the pudding was, so if you were given, say, a fragment like this, would you be comfortable to share on that, or would you be clicking on that? So these were some of the other questions that we asked to the annotators, and to our, the response were something that was favorable, which further motivated us that there is indeed a strong value in generating these fragments in multiple modalities, and that also helps the, and our algorithm was doing well with respect to generating some things that are aligned to the target needs as well as the relevant, and it's also relevant to the article. So to close, I think from this section, so multimodal teasers are very valuable entry points to longer documents, and in this particular work, we were going after generating coordinated fragments, and we had a method for creating teasers for a longer article. And this was actually some work that also had some press coverage from TechCrunch and others when it was sort of showcased in an external customer event. And again, so there are multiple applications of this, right? I think this can be an entry point into a larger document, or it can essentially be an entry point or help. I mean, it can help create a lot of this homepage cards that several websites have that are personalized for different users and auto-generated. So that was at least the initial use case that had the press coverage. But I think there is one open challenge out here, right? I think in this case, there were a few psychological studies that we based this on, and we tried to quantify them and get into the multimodal fragments. But the whole notion of this multimodal composition is very much open, and there are not many work that address that. Like by multimodal composition, I'll also cover in the next work what could be, what I feel is a logical next thing. But so what needs to go in an image and what needs to go in the text? And if something is already covered in the image, can you essentially tailor the things that go into the text appropriately? So this is something that we, as someone who is putting together the slides and other things, we make some of these choices. But can a generation engine account for some of these things, the content semantics across multiple modalities? That is really an open question that is not, not many work is happening in that space, and that is something that is worth solving, is what I feel. So, well, yeah. 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 Images from other places, but text is largely from the document. So image from other places, because often we figured that there are not many documents that are visually rich, which limits the visual assets that we can provide them. So that was the challenge. So which is why we resorted to external repositories for the images. And as you will see in the subsequent work, when we were going into doing a similar thing for videos, there is no dearth of images in that case, right? I think it is just, you can just take, there are several frames. Now it is more about choosing the right frame. But here there was a dearth of images in the input documents, which may not always cater to all the needs, even though the content was catering to that. So that is why we had to go for an external repository to embellish that part. Cool. So now going on, right? I think moving on. So once we were looking at the summarization sort of an angle to the multimodal problem, then the next question that we went after was more around the lines of multimodal answer generation, similar to the first experiment that I had shown about the questions and how do we generate multimodal answers. So here again, the major challenge is if you look at the existing literature, there are different variations of the question answering that are spanning multiple modalities today, like say the visual question answering that essentially looks at an image and tries to answer questions which are in the textual modality. And then there are these chart question answering where people look at, say, some statistical charts and try to answer that. And then there are these recent works around many modal QA, which looks at multiple modalities simultaneously and try to answer questions on them. But I think one major shortcoming of all these works is that the output modality is by and large in the textual thing, and our motivation, like from before, we believe that there is a lot of value in the output being in the multiple modalities that are coordinated. So with that, I think that was the with that as a motivation, we wanted to do something like this, right? Where you have a multimodal document, you have a question, and we want the answer to be in multiple modalities, largely again going back into an image text combination. More formally, this is the problem where I have a collection of input text with some related images, and I want to extract a multimodal answer from this combination. And in this case, we are not necessarily going into an external repository because because the answer we wanted to just extract from the input collection, because I think the precision that is required in the answers are much higher. So we didn't want to, didn't want to just give up on that one. So therefore, for a higher precision, we just assume that the image is part of, at least there is a closed set of collection from where we can take that image rather than an open set from where we were doing it for the previous case. So, but however, I think there is one problem. There are not many existing data sets that can cater to this problem but there were two observations that we made. So the Wikipedia, it has a lot of text and image in their articles, and if you go and look at a lot of the existing QA data sets, say so they have most of them, they have essentially taken their core passages from Wikipedia. So we essentially wanted to use this to curate a data set, wherein we used MS Marco and natural questions data sets, which had passages from Wikipedia. We went and crawled the corresponding Wikipedia pages, and we scraped all the images in those articles. And this resulted in some collection of multimodal documents from where there were, so if that data set as such, what it would be is there is a multimodal article, there is a question, there is an answer. It still doesn't address the multimodal output part. So for that, we wanted to have some sort of a mechanism by which we define a supervision on the images to first identify some pseudo images that will go well with the answers. So this what we were calling as proxy supervision scores, and the idea was, I think this is first in our attempt towards generating or curating the data set. I'll come into how we verified these hypotheses and how this yielded the outputs in a bit. But I think for the proxy supervision scores, which we were using to identify what are the closest images, we used three heuristics on this here. One is the proximity of the image to the actual answer passage, more geometric proximity. And then the proximity or the similarity of the image caption to the answer passage, and the similarity and semantic similarity of the image caption to the question itself. So we were just using an averaging of these three scores to come up with what we were calling as a proxy supervision score. And the data set need here is, I think we wanted, we use these scores as, say, some sort of a guidance as which image could potentially go well with the answer. But this can turn out to be very noisy as well. But I think getting a whole sort of annotations were expensive. So what we did was we had a baseline annotation where we didn't expose any of these proxy supervisions to the human annotators. But all that we provided them was a passage, a question, and the answer, and the entire collection of images that were there in the article, and asked them to choose one image that would go well with the answer. And they were also given an option to choose none of the images go well with that one. And we collected, this was easier because it was an easier and a less, a task that will require lesser trained skills. And so we wanted, we had about 10 annotations per questions, and we collected such a data set. And we didn't use this for any of our training purposes. We just wanted to use this as a gold test data set. So that, and so in order to just address the scale of data annotations that we will need for a typical deep learning model. Now, for our training, for our model, we were introducing what we were calling as a mixed BERT, which was a multimodal extractive BERT primarily for the question answering. Again, the motivation here comes the choice of the BERT architectures and these things came because there was a lot of success of BERT in the textual question answering, and the visual transformers and this multimodal transformers were on the rise, and we wanted to just leverage some of the models like Unitor and adapt them for this task. And so it's similar to Unitor, which has a stack of two stacks of visual and language transformers. We had two stacks, one that was taking in the whole set of images that were there in the input, and the other was taking the textual stream that was taking the whole sequence of input passages along with the questions as well. So the textual stream again is very similar to the typical BERT-based architecture. We just leverage we just retained it as is, but with just one modification where at the higher layers we added the cross attention blocks, because we believe that there is a lot of value in learning from each of these modalities and in the quest towards the output answers. And the visual streams, I think it takes every image as an individual token in the form of their VGG features, and they don't use any visual self-attention because we didn't feel the need for one image to attend on the information from the other image. We just considered them to be largely independent. And now we pre-trained the visual stream with our proxy supervision scores, and we also pre-trained pre-trained both the visual and the textual part with conceptual captions. And this was a pre-training task, wherein we had, the conceptual captions are a set of images and their captions, and we essentially try to, we gave the, on the textual part, it is simple, right? I think we just used the captions and trained it on the MLM. For the visual pre-training, we essentially gave it about the actual image and about 3 to 5 images that were different from the original image, which we were calling as a negative image. And the pre-training task was to make the model predict which was the actual image. So the hypothesis here is that a good multimodal transformers, for the purpose of this question answering, it should be able to identify the right textual answer and identify the right image that will go well with that one. So this pre-training task, where we are having a ground truth with the actual images and their caption, it helps in identifying, in matching, doing this semantic mapping between the answers and the textual answers and the images. And with that, and I'll show you the performances in a bit. But so by and large, to summarize the core architecture here, we leveraged the Unitor-based, we extended the Unitor-based architecture, pre-trained the visual and the textual layers, textual transformer parts with the conceptual captions, but we just added a cross attention layer between the text and the image part. So as a baseline, we just took a simple BERT-based question answering to get the question answers, and then used a Unitor-based model to find the best accompanying images that should go with that one. So we had different variants, but I think the key takeaway out here was that we had a good performance with respect to the by our best model, right, in terms of both the root scores and as I'll show you subsequently. But I think the key takeaway, at least here, is the following. The extract and match, remember, was based off of the state-of-the-art BERT question answering model. So the expectation was with a multimodal model, we will match the textual answers, but we will add additional layers with the image answers. But as we were observing, we had an improvement in the performance even with for the textual answers, even in the root scores. The which confirmed our hypothesis that the cross-modal attention that we introduced in our architecture that attends to the images in the input article, it adds a lot of value in enhancing the output answers, even if it was just the textual modality. And this is one hypothesis that was also confirmed, that has also been confirmed in several works on the multimodal summarization, where just attending to the non-textual part of the input adds a lot of value and the quality to the output that are being generated. Now for the actual image modality itself, we observed that our our best configuration, it essentially had the best, it was able to choose the right image that was that at least was closer and was semantically matching. But again, as I said, this was not something that this is not the only thing. This is still empirical, right? So this is where we used the data that we annotated from the human annotators, and we went and looked at what were the images that people chose, and we compared the precision of our model against our model's ability to choose the relevant image from the input collection and compare it with the human annotations. And this, we believe, I think this is to see how close we can get with a human's choice. And we found that I think at the precision at one, I think that wherein the image that the most of the humans felt was appropriate was something that we choose. It was almost about 40% of the cases. But at least if we are looking at the top 2 or 3, I think our selection criteria was, I mean, our selection was getting better and better. I think this is at least an initial work in this direction. But I think there is, I mean, as we were doing this work, right, I think one natural side effect of the way we were modeling and our Mixbert architecture was that it was getting the answers were modality agnostic. In the other sense, I think in the previous work, we forced the output to have an image and to have a text and nothing. I mean, but in this case, whether an answer should have an image or whether the answer should have a text or whether the answer should be an image or a text is something that is learned by the model as a byproduct of our entire setup. So we did find cases where we had image only answers, we had image and text combinations and the text only answers, because that was something that the model was starting to learn given the entire training setup. But I think the major takeaway was this was one of our, therefore we call this as a modality agnostic question answering, because we didn't want the output, the whole model was agnostic to the output modality. And we had an interesting data augmentation mechanisms to bootstrap the whole setup. But there was still an open challenge out here where there are some questions that needed inferencing from multiple modalities. That was something that we didn't really address here. We were still looking at images and this thing, but sometimes the inferencing can be several layers, right? So that, I mean, those sort of things are very much open, and that would probably need a more careful curation of an appropriate data set, and then utilizing it for developing more more suitable models, but at least that was something that was left as a future work in the context of this one. Now, I have about 5-10 minutes. Sure, I'll quickly go through the last part. So because I think so far, I think what I had motivated was there is a lot of value with generating this multimodal fragments, was first up as a teasers and next up as a sort of an answer to a problem. But in the last problem, we were trying to do this as a sort of a quick way of consuming through a larger video. And again, the idea was, I think videos are largely engaging, and today that is actually increasing in its the spread in the online world. But longer videos are always problematic, right? I think you don't often get to, you don't get time to look through all the videos, including, I think, as this recording goes out, I think people are going to, there won't be patience to go through the entire video. So we were essentially seeing if there can be a nonlinear mechanisms of consuming this video. And our proposal was to consume this video through a sequence of personalized multimodal fragments. Again, the multimodal fragments, we retain the same definition as an image and the text combination. So there are lots of benefits. Say, for example, I have a video here about, say, some Italy travel video or something. So it provides an understanding of the content within the video, even without watching it. Here, I have not played that video at all, but already as we go through these fragments, we know that this is about a travelogue, and then the person is talking about, say, some photo shoot experience, some shopping experiences and things like that. So it provides a quick sneak into what is underneath the video, even without going through the details. And it also, if these fragments are used to take us into the appropriate parts of the video, they can act as say some quick navigation tools. And finally, I think if these fragments, I think connecting it back to the first talk that first paper I was touching about. So if these are tailored to what the users are looking for, then for a longer and longer videos, you can essentially create these fragments that are more suited for someone who is looking at that one. Say, if someone is looking for an educational content in a long video, you can generate, you can have more flavors of those fragments and then keep a lesser flavors of the other parts of the video. So again, the problem here is, given a video, can we essentially convert it into a set of interrelated fragments, and that can again be suited for, convey the same information and also act as a navigation tool. So I'll skip the prior works. So what we were doing was essentially 4 key steps, where first, from every image, we generated the visual and the auditory information. From the speech, we, largely we assumed that these were speech related data. We didn't necessarily account for, say, the music and other kinds of audio, but we, from the audio modality, we extracted the ASRs, and then we generated the scripts, and from the visual modalities, we generated the keyframes, and we used this to create what we are calling as a contiguous clusters. So if a standard keyframe extractors or the sentence segmentation, they just break it at sentences or smaller pieces of videos. But what we want are, say, some contiguous semantic clusters. So we essentially use a clustering that simultaneously runs on both the image and the text modalities to come up with multimodal segments, each of them represented by the talking scripts of the corresponding parts along with the keyframes from that part of the video. And then once we have that, for every segment, we generate a representative multimodal fragment, which is similar to the multimodal teasers that we had generated, where for every segment, we wanted to generate one candidate image and one candidate text that is a good representation of the underlying content. And then we tailored that into the, and similar to what we did in the teasers, we tailor even the selection and the styling of this output to the target user needs, which again was modeled very similar to the first work. But the other interesting thing with video is that, unlike a document or unlike just a text article, the video has a temporal direction, which can also be tailored. So for that, we essentially take these multimodal fragments and we ran an information gain based optimization routine to reorder them into an order that will cater better to the needs of the consumer. So here we accounted for these 4 aspects, right? One, so because when you reorder the fragment, we should not there should not be any chunkiness, or there should not be any choppiness in the fragments. So we wanted to optimize for the overall coherence in this order. At the same time, we wanted to maximize the similarity to what the end user was looking for. And we also wanted these fragments to be relevant and also add to the overall diversity. We factored them into an optimizations routine. And similar, again, I'm just keeping this because there are a lot of overlaps with the first part of the talk, where we model the user preference from the same data set, but now with the videos that were also released as a part of that data set. And so just the whole summary of the entire approach that I just mentioned. And so we actually tested this on different types of videos, like entertainment videos and the lecture videos and the tutorial videos across different durations. And again, like the previous works, we had both the empirical and the human annotations. And I'll just quickly talk through the takeaways here, right? Our baselines were around things that were looking at multiple modalities and generating, say, some captioning systems or something like that, where they were good at, say, things like generating some relevant image modalities and things like that, but not on the holistic problem. And okay, so let me just move into the qualitative side. I think that would be more conveying of the output here. So there are mechanisms in these, recent works that generates a sequence for a visual storytelling. So there they are unconstrained generation, but therefore they have very low relevance to the input videos, but they provide a very coherent sequence of fragments. So that was what therefore I think that was a major shortcoming of say the lines of work around visual storytelling. And the audio visual captioning, they are very good in capturing the semantics, but there was very little that of the fragments that are generated that had to do with the input video. But and similarly, say the video summarization. So this is also somewhat similar to the whole literature on video summarization. But I think unlike video the existing summarization works, they are largely focused on the visual modality only. They don't necessarily go into the auditory modalities and the other channels. So that is a major drawback, and therefore that is where these methods fail. And on contrary, our work was from our this thing, I think it was clear that from our human experiments, they felt that the fragments generated by our approach, they are good in summarizing what is there in the video. To test that, we asked people to watch the video and summarize it, and just consume our fragments and summarize it. And that overlap in a large human experiment showed that our fragments are indeed summarizing the underlying content. And we also asked them to watch both the video and the fragments to test on the non-linearity of the consumption. But I think, again, let me skip through that. I think any details on this one, I think feel free to reach out to me if you want more details, or there are more details on the paper. But the key takeaways here is that we have generated, we show that the multimodal fragments are also a good way of consuming videos, and they can inject some notions of non-linearity in the way we consume longer videos. And there is a lot of value that we found that the users were getting when they were doing the consumption in this fashion. So to close, so the coordinated generation in multiple modalities is far from being a completely solved problem. But as I illustrated, there are a lot of applications of this in from the consumption space. So I demonstrated a few of these in generating the teasers to the documents, or answers to the questions, or sort of acting as a guide to the videos. But there are much more, and we are very actively working on this and many more topics. Like, I think again, to close, my own team, we are working on this multimodal generation, some sneak of which I gave here. We are also looking at, say, some cross-modal translations and problems around how do we add intelligence to contracts and various documents, and how do we extract key information from, say, the documents and various visual modalities. And with that, I would like to thank you for your time and quick PR. And I think I'm actually actively looking for folks, and if anyone is in the job market, feel free to reach me. And if there are any questions, open. Thank you.
So anyone have questions here?
So a quick question about, see, the video part, right? The
Yeah.
auditory part is anyway tied closely to the video.
Yeah.
So you're not separately generating the audio output, right? It just
the
goes
text. Yes.
hand. So would you still call that a multimodal thing, because it's anyway clubbed together, right?
Because the multimodal notions of multimodality gets a bit complicated in video, because although we call video as a modality, that is inherently a multimodal thing, right? I think so. It is essentially one multimodality into the other multimodal. So that is where it sort of seeps into the other domain that I was talking about. That is the cross media stuff. It is one multimodal representation to the other. But I think in that case, we didn't necessarily, that was the other thing that I was mentioning upfront, right? In a video, there is already a whole bunch of information that is out there. So we have to reduce that and put into another multimodal representations. So that is what we did here.
Yeah. And a question related to that was about, you said you had certain people volunteer in summarizing, right? How big a sample do you need for something like this? Now, how much did you have?
So we actually
case?
annotated with about 30 documents on mechanical Turk. And these were, particularly these were very subjective, and this also requires a deeper thing, right? So I think we went through 2 rounds of this thing. So I think we asked, independent annotators, and this was sort of a more extensive task where we asked them to look at it. And so the time commitment that we needed from the annotators was long. But at least for our experiments, we used about 30, I think 30 or 50, one of these numbers. But I think we had about, no, actually 30 10 of each, 10 short videos, 10 medium videos, and 10 long videos, and ask them to summarize it. So there were about 5 annotators who did for everything. And then what we did was so that is where it scales up, right? 30 videos, 5 annotations, it already goes into about 150 annotations, right? And similarly for the fragments. And we wanted to look at the semantic, I mean, the similarity of the summaries that were written up. Okay, thank you.
There are online questions.
There's something on the chat. Can this method be used to generate YouTube shorts? I think we tried to do this more for not as a YouTube shorts, but more for what Google has subsequently released. But yeah, so we didn't essentially do this for the YouTube shorts, but we used this. I think what Google has now released in their the timeline charts, where you can automatically navigate to different parts of the video. We wanted to enable a nonlinear version of that one. Text to image concept is something.
Can you read it out loud?
Yeah. Yeah. So the question is on the text to image concept is something on the similar lines, Google reverse image engine. So I think that goes back into one of the thing that I started with, right? There are lots of work on the text to image, text to videos, and those sort of things. But one real problem, I mean, all of them ultimately they end up generating in a single modality. While the understanding of the semantics right now have started to span multiple modalities, the outputs are still in a single modality. So that is the challenge. And that is what we are trying to address here in a coordinated ways. Hope I answered your question, Pranav. So, okay. So that is an area that we are active. Okay, sorry. So the question is contract intelligence and generations, and please explain. Okay, so in the enterprise domain, there is a lot of effort in the post-pandemic world where there is a lot of these contracts and signing workflows that are going online, and so this includes creation of contracts and putting together the clauses and ensuring that there is a good amount of compliance between the each clauses and also seeing how and when someone signs these clauses, is there a simple way of providing that understanding? So we are essentially looking at that spectrum in our research works. Okay. How an EC engineer can contribute to Adobe? I was I have my bachelor's in electrical engineering and master's in electrical engineering. I have been with Adobe for 10 years. So yeah, we'll find ways.
So yeah, can we enable the mic for Professor Kriti? I think he wants to ask a question. So meanwhile, there was this one question: can this method be used in online consumer reviews? You skipped that.
Did I? Which one?
Can this method be used in online consumer reviews?
Oh, okay. Oh. Online consumer reviews. So we didn't necessarily, I think, so on, yes, I think that, as I said, I think our idea was to make this, I think if you're talking about the videos, yes, I think we were trying to bucketize the videos and trying to use that as an entry point for the videos. And yes, we have tried with largely with the entertainment and tutorials and this thing, but there is no, I mean, the reason for the breadth of those videos is to see how it generalizes. So I think it will.
So Kriti, you have a question you want to ask?
Yeah, I have a question. What is the order in which you would deal with these modalities? What does it depend on primarily?
So yeah, that's a good. I mean, so when we started this work, I think we started with the strengths and weaknesses of each of these modalities. Say, for example, modality like image, it has it has a very strong, it can leave a very strong impact, but there are studies that show that if you want to emphasize certain things, then the text becomes more, the text is the go-to modality. But I think, so there were some works that look at the strengths and weaknesses of these modalities, and that is what we used in the ordering the importances or what we want to put in the modality. So if your question is also about tackling which modality is more important than the other, so increasingly we are seeing that the visual modalities like videos are getting much more engaged. So some of our recent works is looking at making it more visual from a text-heavy document. So that is the
Okay.
So I know there are a lot of interesting questions coming on, but we are well over our time. So let's thank Balaji for a really engaging talk
thank you.
and the small.
Thank you. Thank you.
Thank you, everyone. Yeah. And those who are here physically, you get a bonus. You have some tea and snacks outside.